My name is Geissler. I am doing my video explanation for question 3 on the chapter 29A homework sheet. So yeah, let's get started. The loops are 10 centimeters or 0.1 meters in diameter and 10 centimeters, 0.1 meters away from each other. Point P is exactly in the middle point between the two loops. The direction of the current in each loop is shown in the picture, which I have drawn out down here where my mouse is. And its magnitude is equal to 1.3 amps, meaning the current is 1.3 amps. Part A, use the right-hand rule to determine the direction of both magnetic field contributions. You must draw a right-hand simulation, the situation on top of the situational diagram. Now, I drew a few pictures. This first picture on the left is just like almost one-for-one rip of the picture provided on the assignment. You got the first loop here, the distance between it and the point, the distance between the second loop and the point, and then the second loop here with both having the same diameter of 0.1 meters. And then the current is flowing down and to the right. To the right is just a top view of the loop itself. I tried to shade the loop just to make it a bit more 3D and easier to read for me, with the current being inside going around in circles, and then the magnetic field coming out of the loop from the page from our view. And then again, the diameter is 0.1 meters. And then finally, there's this final picture on the right, which just shows the loops and the directions of the magnetic fields coming from the from the loops. To use the right-hand rule to find the direction of the magnetic field and the current and all that, you just curl your fingers around the current, which in this picture, you'd curl your fingers to the right and then have your thumb pointing out towards you, essentially. Part B, create a free body diagram for point Z, or point P, sorry. This is a small diagram, I understand. Both magnetic fields are pointing in the same direction, hence why this is a very thick arrow. And then you'll notice here that this is in the Z direction. I'll come back to that at the end. Finally, part C. I had to split this amongst 2 pages, so bear with me. Calculate the magnitude and direction of the magnetic field at point P for the configuration below, meaning the pictures as noted before. So the equation for the magnetic field of a loop or ring is equal to mu naught over 2 times the current times the radius of the loop squared over the distance z squared from the loop and point plus the radius squared. Add those two together and then put those to the power of 3/2. And then down below that is just all the numbers for the equation. Mu naught is 1.257, 10 to the negative 6. The current is 1.3, radius 0.05 meters, distance 0.05 meters. So we got to find the magnetic field of both loops, and thankfully these have the same numbers throughout. Both of them have the same radius, both have the same distance from the point, both have the same current. So you can actually use the 2 equations and both equations the same way, and you'll get the same answer for both. Obviously, plug in all the units up here, gets you down all the way down to 5.77 times 10 to the negative 6 Tesla. That's the same for both. Again, throw all the units over here, and then it comes all down to 5.77 times 10 to the negative 7th. And then on the second page, to find the total of the magnetic field, you have to add both of these up. Normally, they'd likely be a second magnetic field that's taken away, or maybe a third. In this case, both of them are pointing in the same direction, so both of them are going to add up to each other. So it's 5.77 times 10 to the negative 6 Tesla plus 5.77 times 10 to the negative 6 Tesla, which gives you 1.1554 times 10 to the negative 5th Tesla. And then earlier we had this free body diagram labeled Z. That is due to both of the magnetic fields pointing in the same direction and Z being that direction that the whatchamacallit, that the magnetic fields are pointing. That's also the same name for the direction of the field, or the distance of the field in the B ring. So that's why it's in the Z direction and not the Y direction like we're more conventionally writing it as. So yeah, this is my video explanation. I hoped it helped, or if it didn't, then I hope you enjoyed this in whatever weird way you did. Thank you and bye.